November 2024, paper 2, variant 3. Question 1. Which list contains only vector quantities? Acceleration, distance, no, distance is wrong. Electric field, momentum, and weight. They are all vector quantities, yes. The graph shows how the velocity of an elevator varies with time. The elevator starts from the third floor of a tall building. Point P indicates the start of the elevator's journey. When is the elevator on the third floor again? So at point P, it was at the third floor, right? And this is a velocity time graph. Velocity time graph, someone might say, well, from Q to R, you have reached the third floor again, right? Wrong, actually. Wrong. Why? Because from Q to R, this just indicates that the elevator has stopped. Does not indicate that it has returned back to its original position. How can I find that it has, or how can someone say that something has returned to its original position by finding the distance traveled, right? So if I travel with my car, for example, from point A to point B, I need to go back to point A by traveling the same distance in the opposite direction. Again, by traveling the same distance in the opposite direction. Okay, where is the distance traveled in this graph? The distance traveled is the area under the graph. So the initial distance traveled was from P to Q, this area, right? And then this means that it has stopped at some floor, whatever, right? Q to R, he's at rest, the elevator is not moving. But then from R to S, what's happening? What's happening? He's moving with a negative velocity, right? A negative velocity indicating that it's moving in the opposite direction. With an opposite direction, meaning that it's moving, let's say, backwards or returning back to the original position. So at point S, it has reached its original position. From S to T, it has reached its original position. Why? Because you have a, let's say, positive velocity first, and then you have a negative velocity, right? You can say positive displacement and negative displacement. Displacement means that you have changed your position from point A to point B, and then you are displaced back from B to A, indicating that you have returned to your original position from S to T. Okay, from S to T. Okay, question 3. An object of mass 1 kilograms, 1 kilogram, is at rest on Earth, and an identical object is at rest on a planet with a gravitational field strength twice that on Earth, right? Twice that on Earth. What happens to weight and what happens to the acceleration when the same horizontal force is applied? The weight is doubled. It's quite obvious, right? And someone might say, well, the acceleration would be halved, right? Someone might say that, which is wrong. Why? Actually, the acceleration would be the same. Why would the acceleration be the same? Because if you think about it, force equals mass times acceleration. The same, okay, horizontal force. We're not talking about the vertical force in this question. We're talking about the horizontal force. Force equals mass times acceleration. So if you have the same force and the same mass, then the acceleration will be the same. Same force and same mass, then the acceleration will be the same. So it's equal to that on Earth. Force equals mass times acceleration. An engineer researched the density of different liquids being used as coolants. None of the liquids mix with water. Each liquid is poured in turn into a container of water. The density of water is 1000 kilograms. Which liquids rise to the surface? The only liquids that rise to the surface are the liquids with a density less than 1000, which is X only. Diagram shows a car moving along a road. The force due to the engine is 1500 newtons. Total drag force is 200 newtons. What is the motion of the car? What is the motion of the car? If the driving force is greater than the resisting force, then the car is accelerating, or you can say that the speed is increasing. A pair of cutters is used to cut rope. Where should the rope be positioned? And where should your hands be positioned? The rope should be positioned at point Q to experience a larger moment, maybe, while your hands should be positioned at point S, yes, to experience the or to exert the greatest moment. So Q and S. Q and S, yes. An object has a mass of 20 kilograms, velocity changes from 6 to 10. What impulse, mv minus mu, the change in momentum, changes from 6 to 10, so 20 times 10 minus 20 times 6, which is 80. Useful energies obtained from different resources. For examples of energy resources are listed. How many of these resources depend on radiation from the sun? How many of them depend on radiation from the sun? Water waves, yes. Geothermal, no. Wind, water behind the hydroelectric dams, yes. So 3 of them. What is the decrease in gravitational potential energy as it moves from P to Q? In the gravitational potential energy, so mgh, right? The mass is 2 kilograms times 9.8 times the height, 5. Why? Because we're talking about gravitational potential energy, so we need the vertical distance only. We only need the vertical distance, so this will give you 98 joules. Diagram shows the path of a long jumper. Point R, okay, where she lands on the same horizontal level as point P from where she takes off. The long jumper experiences air resistance and as she runs and jumps. Which graph shows how the store of kinetic energy, okay, how the store of kinetic energy and the store of gravitational potential energy of the long jumper vary with time? Okay, so you have the kinetic energy, which is the dotted line, the gravitational potential energy, which is the solid line. Can I cancel out A and C? Can I immediately cancel out A and C? I can do that. Why? For a very simple reason. The kinetic energy is not zero. The kinetic energy does not reach zero. While she's jumping from P to Q, at Q, she still has some kinetic energy. She didn't stop. She's not, for example, vertically jumping upwards. No, she's not jumping upwards. She's jumping kind of in horizontal motion. So at Q, I mean, she still has some kinetic energy. It does not reach zero. It does decrease, yes, it does decrease, but she does not have zero kinetic energy at Q. So I'm stuck between B and D. I'm stuck between B and D. Should I choose B or should I choose D? Well, D seems like a very good answer, doesn't it? But in fact, D would be wrong. Why would D be wrong? Because D shows that the kinetic energy is perfectly equal to the gravitational potential energy, right? Kinetic energy is perfectly equal to the gravitational potential energy, which is wrong. In this case, in this very rare case, the gravitational potential energy and the kinetic energy are not perfectly equal. Why? Because there is some air resistance. There is some air resistance. Some of the energy is lost due to this air resistance. Some of the energy is lost due to the air resistance. So it would be B. The gravitational potential energy might be slightly less than the kinetic energy. Okay? Now, four tanks contain water to the depths shown. At the bottom of which tank is the pressure due to the water greatest? Due to the water greatest would be A. Why would it be A? Because it has the greatest depth. Doesn't have to do with the area of the base at all, this question. Question 12. A gas is heated in a sealed container. The volume of the container does not change. What happens to the particles of the gas? As they get heated, they gain kinetic energy. The average distance increases. No, it's a sealed container. The average kinetic energy increases. Yes. Air is sealed in a syringe. Okay, slowly compressed. The temperature of the air stays the same. Which statement about the air is correct? Which statement about the air is correct? as you push the piston inwards, what happens? Does the pressure decrease? Definitely does not. It increases. Because its particles now hit the syringe more frequently or more quickly. Hmm. Do they hit it more quickly? No, they do not. Why? Because the temperature is the same. So more quickly is wrong. More frequently. Which statement about the evaporation of a liquid is correct? Evaporation happens from the surface. The least energetic molecules, the most energetic molecules escape from the surface, and the temperature, yes, decreases, not increases. Cooling effect. A solid is heated, causing it to expand. Which effect does this have on the mass and the density? Mass does decrease. It stays the same. The density decreases. The volume increases and the density decreases. A glass tube containing water is heated at the top. The water at the top boils, so you have boiling happening at the top of the water while the bottom remains cold. This is still cold water, which explains why the water at the bottom remains cold. If if the glass was a good conductor of heat, it would have transferred a lot of this heat to the bottom, right? It would have transferred a lot of the heat to the bottom. So the water at the bottom would have gotten equally heated up. It would have boiled, right? So therefore, glass is actually a poor conductor of heat, right? Glass is a poor conductor of heat. Now, as for water, again, the same thing applies for the water. If water was a good conductor of heat, it would have transferred the heat to the bottom easily, right? It would have transferred the heat to the bottom easily, and all of the water would have heated up equally. But water is a poor conductor of heat, again, and that's why the water at the bottom stays the same or remains cool. Remains cool. A vertical stick is dipped up and down in the water at P. In 2 seconds, 3 wave crests spread out. Which statement is correct? Which statement is correct? X is the amplitude of the wave. X is not the amplitude, X is the wavelength. Y is the wavelength. No, Y is not the wavelength. Each circle represents a wave front. Wave front. Yes, it is a wave front. The frequency is 3 hertz. How do you know? Did I say that these 3 waves have been created in 1 second? No, I have not. So it's when you see each wave is a wavefront, yes. Seismic waves from the epicenter take 100 seconds to reach a point 300 kilometers away. When they arrive, they cause the ground to vibrate at the frequency of 2 hertz. What is the frequency? What is the wavelength? Can I find the wavelength? Yes, first of all, I need to find the speed. Speed equals distance over time. Distance is 300 kilometers and the time is 100 seconds. So the speed is 3 kilometers per second. To find the frequency, you'd say it's the speed over the wave. No, he wants the wavelength. I'm sorry. To find the wavelength, okay, to find the wavelength, it would be the speed over the frequency, which is 3 over 2. 3 over 2 is 1.5 kilometers. Which diagram illustrates diffraction? Diffraction is A. Quite simply. A single ray of light is reflected by 2 mirrors. The ray of diagram shows the ray, okay, in mirror 1. What is the angle of refraction at mirror 2? Okay, this is interesting. Actually, this is a really nice question. Let me zoom in and try to draw it as carefully as possible. Okay, this question will need you to kind of use your information, everything you know about triangles and math and whatnot. So now you have the ray of light incident on mirror 1 at an angle of incidence 50 degrees, and then it is reflected back and hits mirror 2, right? At this point, there's another normal line, right? We need to find the angle of incidence or the angle of reflection. Okay, not too bad. What is this angle? This angle is now 50, right? This is the angle of reflection from mirror 1. Okay, now let's solve using triangles, using our knowledge of triangles. This is an obtuse triangle, and this angle would be what? What would this angle be? 50, oh, 90 minus 50, this would be 40, right? This would be 40. Okay, not too bad. What about this obtuse angle? It would be 180 minus 60. It would be 180 minus 60, which is 120. How did I find it? Again, it's 180 minus 60, which is 120. So now you have two interior angles, 120 and 140, which give you a total of 160. Therefore, this angle, to find this angle, it would be 180 minus 120 and 40, right? Which is 20. So this very small angle, let me write it down. This very small angle would be 20. Can I find the angle of incidence? Now, the angle of incidence would be 20 or 90 minus 20, which is 70. You have to be very good at triangles to be able to solve this question. Okay, so the angle of incidence is equal to the angle of reflection, which is 70. Okay, just take a screenshot of this question or something, try to solve it again using your knowledge of triangles. The angle of incidence would be equal to the angle of reflection, which is 70 degrees. Yeah, I had to zoom in a lot. Now, moving on. Which diagram shows the effect of a converging lens of a beam of light? You have parallel rays. These parallel rays would be converged into the focal point, as in B. Which three regions of the electromagnetic spectrum are used in the applications listed? So we need sterilizing water. How can I sterilize the water? Using ultraviolet. Optical fibers using infrared or visible light. Satellite television signals using microwaves. Mobile cell phones also using the microwaves. So the only correct answer would be B. A man stands 110 meters from a high wall, makes short, sharp sound. The sound in air is 330 meters per second. How long after making the sound does he hear the echo? So the echo to distance over time. To find the time, it would be to distance over speed. 2 times 110 over 330, giving you a time of 0.67 seconds. How does the strength of the magnetic field vary with the position along the dotted line P or Q? P or Q. Okay, at P it's very close to the magnet, so it's very strong. It's constant, it's not constant. It is not constant. Why? Because at R, it's very far away from the magnet, right? So at R it's weakest. It is the weakest. At Q it's strong, and at P it is strong. It's strong at P, reduces along the path. It's weak at P, no, it's strong at P, decreases to a minimum at R, increases towards Q. Yes. Okay. Diagram shows a charged sphere and the direction of the electric field at point X. The direction of the electric field at point X. What does this direction mean? If the if the direction of the field is inwards towards the sphere, meaning that this sphere is what? This sphere is negatively charged, right? The sphere is negatively charged. Why? Because the magnetic field lines are going inwards towards the sphere. An electron is placed at y, so this is an electron. Negative and negative, it will be repelled moving downwards. It will be repelled moving downwards. A battery moves 3 coulombs of charge around the complete circuit. The battery transfers 12 joules of energy. Can I find the EMF? Yes. EMF, V equals E over Q, right? So 12 over 3, which is 4 volts. 4 volts. Question 27. By which factor does the resistance of the putty decrease? This might seem to be a bit difficult, this question. Let's solve it and try to simplify it as much as possible. A cylinder of conducting putty has length of L, diameter of D, resistance of R. Okay, it's now molded into a cylinder of a diameter 2D that has the same volume. Volume. So basically, the area, the diameter has increased, the area has increased. Let me try to draw it again. So it would somehow look a bit like this. Okay, the diameter has increased a bit, but the length will decrease, right? The length would decrease. So it looks, let's say, somewhat like this. Maybe, okay. So the length will decrease. The length, this is the new length, right? It would decrease. The diameter has increased. The diameter has increased. By how much has the diameter increased? It has decreased. It has increased to 2D. When you increase the diameter two times, what happens to the area? What happens to the area? The area increases 4 times, right? So the area has increased 4 times. The area has been multiplied by 4. Therefore, the resistance will be divided by 4. I'm not done yet. I am not done yet. Why? The solution wouldn't be 4. The resistance will not decrease by 4. Why? Because you haven't taken into the factor that the length has also changed. The length has decreased. Why? Because this is the same volume. This is the same volume. So the length will now decrease. If you increase the area 4 times the area of the base, it's the same volume. Isn't this the volume? Volume equals the area of the base times the height, right? Area of the base times the height, or area of the base times the length. Isn't this length the height? Isn't this length the height? Yes. So if you decrease the area by 4, what if you increase the area? We have increased the area, yes. If you increase the area by 4, what will happen to the height, or what will happen to the length? It will be decreased by 4. Why? Because it's the same volume, right? It is the same volume. So increase the area, decrease the height. So as the area increases by 4, the resistance decreases by 4. As the length now decreases by 4, therefore the resistance will also decrease by 4. Therefore, the total resistance will now be decreased by a factor of 16. 4 times 4 is 16, right? The total resistance would be decreased by 16. It's a rather tricky question, I know. You can solve it numerically, even though for this question, numerically might be a bit more difficult. I'm just saying, might be a bit more difficult, but again, you can do it if you want. You can give the length whatever value, and you can give the diameter whatever value you want, and then find a volume and do as you like. Just do as you like. Okay, but for the sake of this question, you can just solve it this way. Say that the area has increased by 4, therefore the length will also decrease by 4, and the total resistance would decrease by a factor of 16. I hope it is clear. Which statement describes how a diode operates in an electrical circuit? Diode. A temperature, it doesn't have to do with the temperature. Current becomes too high. No, it's not a fuse. It only allows current in one direction. Yes, this is the diode. It is a diode. Which arrangement of resistors will give an overall resistance of 25? If all of them are 10 ohms, again, we said you need to memorize it. If you have two resistors which are the same resistance and they are in parallel, then just take it as a rule of thumb. The total resistance of these two resistors would be half the resistance, meaning 10 and 10, meaning these two resistors would be 5. So you have 5 and 10, 15. No, this is wrong. 5, this is wrong. 10 and 10 and 10, the total is 30. This is wrong. 5, 10, and 10, so the total is 25. Yes. If you want, you can solve it using product over sum, which would take a longer time, a much longer time. You can just do it quite quickly if you have two equal resistors. Okay. Diagram shows a thermistor potential divider. When the temperature of the thermistor increases, its resistance decreases. As the thermistor becomes warmer. Okay, so the temperature increases, the resistance decreases, and the voltage decreases. If the voltage of Y decreases, then the voltage of X will increase, right? Voltage of X increases and the voltage of Y decreases. You have to write it down this way. It would be much easier to solve these types of questions. An experiment, strong magnetic field provides a force that keeps the charged particles moving in a horizontal circular motion. Horizontal circular motion. Positive particles are accelerated clockwise, then viewed from the above section. Okay. In which direction is the magnetic field? In which direction is the magnetic field? Now, first of all, how can I even think about solving this question? How can I even think about solving this question? First of all, this is a positive charge, right? You have some particles moving, positive particles are accelerated. Positive particles and a magnetic field. Then I will use the Fleming's left hand rule, right? Fleming's, okay, left hand rule, right? Now, you have the direction of the motion. You have the direction of the motion. The direction of the motion at point X, for example, is in this direction, right? It's moving this way. At this point, it's moving this way. Let's say it's moving in a circular motion. So this is the direction. This is the second finger, right? This is the second finger. So if you want, you can place the second finger in this position. The second finger, you have the second finger moving in this direction. So this is the second, okay, finger. How can I find the magnetic field? You have the force. How do I have the force? Isn't this moving in a circular motion? Yes, and when you are moving in a circular motion, the force is always perpendicular to the motion. It's always towards the center. This is the force. This is the force. So you have your thumb positioned in this direction. So the second finger, I know this is a bit weird. Okay, this would be a bit weird, but you have the second finger pointing in this direction, the force pointing towards the center. Therefore, the first finger, your index finger, should be pointing out of the page. Your first finger, your index finger of your left hand, should be pointing out of the page. It's a bit difficult. I know this question is quite difficult because we're used to positioning our first finger first, right? We're used to finding the magnetic field first and then either finding the force or finding the direction of motion or the current or whatever. Never have we found the direction of the magnetic field. It's much more difficult, it's much more intricate, but again, it is solvable. Okay, it is doable. Second finger, first finger, or second finger, then the force, then you can find the direction on the first finger. Index finger would be out of the page. When there is a current in a solenoid, a magnetic field is formed around it. How does the magnetic field change if the current is increased? Magnetic field will get stronger. So the spacing of the magnetic field lines will be closer. Yes, the strength stronger. Okay, which row shows the correct conditions for the efficiency to be as high as possible. For the efficiency to be as high as possible, what should I do to the primary and secondary coils? What should I do to the primary and secondary coils? I should use thick wires, right? You should use thick wires. What about the core? It has to be iron. Thick wires to decrease the resistance. The products of decay of a nucleus of radioactive isotope are a nucleus and a radiation which is emitted. What is the nature of the products? Okay, products of the decay are a nucleus and a radiation which is emitted. A nucleus of an element different from the isotope is formed and both alpha and gamma radiation are emitted. Okay, nucleus, this might seem to be true, right? Let's see. A nucleus of an element different is formed. Okay, no problem. And just gamma radiation is emitted? No, this is wrong. If you emit gamma radiation, then it would be the same element. Nucleus of the same element. Okay, no problem. Both beta and gamma. No, if you produce beta, then it would be a different element, right? Nucleus of the same element and just alpha. Again, alpha would change the element, so the only correct answer would be A. An atomic nucleus decays by one or more radioactive decay process. What causes the proton number to decrease by one? To decrease by one, I know that when I produce an alpha, it decreases by two, right? And I know when I produce a beta, it increases by one. So if I decrease by two and then increase by one, then the total change would be decreasing it by one. So you need to produce an alpha and a beta, and alpha and a beta particle, both. Which definition of the half-life is not correct? Which definition is wrong? Time takes for the count rate to fall to half its original value. Okay, no problem. For the unstable nuclei to decay for half of the unstable, yes, okay. Time takes for the mass of the radioactive to half, okay. Time takes for half of the neutrons to decay. No, doesn't have to do with the neutrons. Neutrons would be wrong. Diagram shows a system to control the thickness of the paper produced by a machine. Okay. The graph shows how the count rate of the detector varies with the thickness. So you have the count rate and you have the thickness. The rollers squeeze the paper when the count rate drops below 12, okay, per second, and then stops squeezing when it rises above 13 counts per second. What is the thickness of the paper? Okay, where is 12 and where is 13? So 12, when it drops below 12 at this point, this would be at a thickness of 0.6, and 13, okay, would be at a thickness of 0.5. 0.6 and 0. So between 0.5 and 0.6, right? Between 0.5 and from the graph. It was as easy as that. From the graph, I drew a line from 12 and I drew another line from 13 and found the range. Table gives the orbital durations of the planets. What is the duration of Mars? Mercury, Venus, Earth, and then Mars should be somewhere between Earth and Jupiter. So the orbital duration of Mars has to be longer than Earth and shorter than Jupiter, giving you only 690 days. Which reaction produces the energy that powers the sun? Fusion of hydrogen. The diameter of the Milky Way is approximately 100,000 light years. What is the distance in meters? 100,000 times 1 light year, which is 9.5 times 10 to the power of 15, giving you a total distance of 9.5 times 10 to the power of 20 meters.